You think your Wi-Fi is broken? It might be just DNS. This is exactly what happened in October 2016. The DNS provider DIN was hit by a really massive DDoS attack, powered by the Mirai botnet. The attack came in several ways, targeting DIN's data centers and making popular websites like Twitter, Netflix, Reddit, Amazon, and many more unreachable. It lasted for hours. We won't go into the details of this attack right now, but it shows us how crucial the DNS protocol is, which I will help you understand today. DNS stands for Domain Name System, and it's the protocol that basically runs the whole internet. It works in the background all the time whenever you're going online, and you're probably not even thinking about it. First, let's just use a simple analogy. DNS is like the internet's phone book. You may not remember that anymore, but back in the day we used phone books to look up someone's phone number, so we didn't have to memorize any of them. Today we simply save contacts on our phones, so we don't have to remember any numbers as well. And that's exactly what DNS does. It's a protocol that resolves domain names to IP addresses. When you browse the internet and you want to go to a website like, for example, youtube.com, which is a domain name, it's like a nickname for a website, but behind this nickname hides an actual IP address. So think of our phone book again. youtube.com is equivalent to, let's say, John Smith, and John has a phone number assigned to him, just like youtube.com has an IP address assigned to it. So the job of DNS is to map the domain name youtube.com to the IP address of the server that hosts YouTube. If DNS didn't exist, we would have to remember the IP addresses instead of website names. So instead of typing youtube.com, you would have to type the actual IP address of the server that hosts YouTube. Alright, let's just dive a little bit more into the details now. And hold on, because it might be difficult to understand everything at first. You can pause the video if you want to take notes or just think about it for a moment. But also don't worry too much if you don't remember everything, because what really matters is that you understand the flow of the DNS query. Okay, so let's start, and let's say you try to reach a website youtube.com. Your computer first checks the DNS cache, the local cache of your computer, to see if it already knows the IP address of youtube.com. Thanks to that, your computer doesn't have to query the DNS server repeatedly for the same website. If the request is not found locally, then something called a recursive DNS server will be checked. This is most likely a server provided by your internet service provider, or alternatively you can choose another server from a company like Cloudflare. The recursive DNS server also has its own cache, and for popular websites the journey usually ends here. But if the recursive DNS server doesn't know the answer, then it will start asking other servers for it. The first server it asks is a root DNS server. Root servers don't know the final IP addresses, but they know where to look next. Now, depending on the top level domain, which is for example .com, the root DNS server will look into the top-level domain server responsible for .com. Top-level domain servers also don't know the final IP addresses, but they know something called authoritative DNS servers. In our example, the authoritative server for youtube.com. And this authoritative DNS server finally knows the IP address that we're looking for. The result of the DNS query will be sent back to the recursive DNS server and then also to your computer. So as you can see, this whole process involves quite a few steps, and that's why the result will be cached both in the recursive DNS server and your computer's local DNS cache, so the lookup is faster next time. And that's it. Now your computer finally knows where to go and the YouTube page can load on your screen. Okay, so before we end that video, I just wanted to show you a command line tool that you can use to check the IP address of a website. That command line tool is nslookup, and first let's take a look at the manual for nslookup. So here you can read that nslookup is used to query internet name servers interactively, and in the description it says that nslookup is a program to query internet domain name servers. And generally I recommend reading more of this manual, especially if you're new to this tool. But let's take a look how nslookup works anyways. So we type in nslookup and we give the domain name, let's say for example youtube.com, and we have the results immediately. So you can see that server that was used to perform this DNS query was 8.8.8.8. This is Google's DNS server. Another one that you could see could be 8.8.4.4, for example. It would be also DNS server for Google. And in the address, this is the same IP address, and 53, which is default port for DNS. Then you can see that non-authoritative answer is provided. It means that the DNS result was found in some of the caches and not in the authoritative server. And the name is youtube.com, and the IP address for youtube.com for the server behind it is 142.251.36.206, and the IPv6 address. And what's also interesting about nslookup is that you can specify what DNS server you want to use. So we could type in nslookup youtube.com and, for example, the other Google's DNS server. And here, as you can see, the result is exactly the same. But we can also check our IP address. So ifconfig, here I have VLAN 0 interface, and on VLAN 0 interface my IP address is this one. This means that it is a private IP address, so this is just an IP address of my device, probably given to me by DHCP. I mean, definitely given to me by DHCP because I did not set it statically. The netmask 255.255.255.0. This means that we have /24, which is 254 devices assignable addresses in this network, but it doesn't matter right now. I just want to show you that we can also use the DNS of our router, of the internet service provider. So in this case, it would be the same subnet as my IP address is in, but with 1 in the beginning. The first assignable IP address is usually the default gateway. The default gateway is the router provided by the internet service provider, which, as I mentioned before, is usually also a DNS server. And let's see if that would work. And it works. And let's just bring up the previous nslookup result so we can compare. As you can see, the answer for youtube.com, for the DNS query for youtube.com, is different when we use this DNS server than when we use the Google's DNS server. You see, the IP address for Google is much different. And this is because one website, one domain name can have multiple IP addresses. This is because the youtube.com is a really huge website, right? And it might happen that one website has multiple IP addresses. And depending on what DNS server you're using, the result will be different. Okay, that's it. If you're more curious about nslookup, then read the manual, try to use it on your own, and see you in the next video.